Welcome in this lecture. This is the fourth lecture in the series of the basic mechanical engineering. In this lecture, we are going to study the diesel cycle. So let's start. Diesel cycle. Diesel cycle is a air standard cycle of CI engine. The CI abbreviation stands for the compression engine. In the compression engine, ignition of the fuel, ignition of the fuel is done by compression. That is, the piston compresses the fuel, and due to the heat generated by compression, the fuel is ignited. Okay. Unlike in the SI engine we know that the ignition is done by spark plug. Spark plug. That it is why called as the spark ignition. Okay. It is The diesel cycle is based on the auto ignition principle, and the efficiency of the auto engine. It is less efficient than the auto engine for the same compression ratio. This is the graph of the volume versus pressure for the diesel cycle. So let's study it. See, from 1 to 2, the volume is decreasing, and at the same time pressure is increasing. So what does we know from it? As the volume is decreasing and the pressure is increasing, compression is taking place. That is, we can say that if this is the cylinder and this is the piston, at 1 to 2 the process is from the bottom dead center to the top dead center. Okay. And one of the important things is that in the diesel cycle air is compressed. Why? Because when the piston is at the top dead center, then the fuel is released. Okay. First it compresses air only, and when the piston is at the top position, then the fuel is released. That is, only air is compressed. See here, isentropic compression of air by piston. Why isentropic? Because the volume is decreasing, and at the same time pressure is increasing. So the entropy remains constant. Due to these two, the entropy remains constant, and hence the process becomes isentropic. Okay. Now see here, from 2 to 3 from 2 to 3 the volume is increasing, but the pressure is constant. See, the pressure is constant. Okay. And volume is increasing, and heat is added. Okay. Heat is added in a reversible manner. Okay. But how is heat added? Why it is the addition of heat? Because due to compression, fuel ignited. Due to the compression, the fuel is ignited in the 2 to 3 process. 2 to the process, fuel is ignited. That is why we say that heat is added in the process. See here, reversible heat addition at a constant pressure. Fuel is injected. Because why injected? Because the compression takes place of air only, and in 2 to 3 the fuel is injected and also ignited due to the compression of air. Okay. Now let's see further. The graph moves from 3 to 4. Okay. From 3 to 4, again the volume is in increase. And pressure is in a decrease. So what does we say? It is expansion. And at expansion work is obtained. Okay. And expansion of what? Here the combustion products, that is the smoke, like smoke, etc., like things get expanded. Okay, see here. In 3 to 4, isentropic expansion takes place and the combustion products expand, doing work on the piston. That is, the piston moves from TDC to the BDC. That is, from top dead center to the bottom dead center at 3 to 4 process. Okay. And now the last process. What does the last process state? From 4 to 1. 4 to 1, the pressure drops. Pressure drops, volume is constant. As the pressure drops and the volume is constant, heat is rejected. Heat is rejected at the constant volume. Okay, see here it is given from 4 to 1, reversible heat rejection at the constant volume. These are the four processes carried out in the diesel cycle. Let's move forward. We have a expression of efficiency. We will learn the formula. Efficiency of the diesel cycle is equal to 1 minus 1 upon r gamma minus 1, r raised to gamma minus 1 in bracket alpha raised to gamma minus 1 upon gamma into alpha minus 1. This is the expression. From the last video, we know that what we know, r is the compression ratio. R is the compression ratio and gamma is the ratio of Cp upon Cv, that is constant pressure upon constant volume. We know that from the last video. Now we have the question, what is the alpha? What is the alpha? Alpha is known as the cutoff ratio. Alpha is known as the cutoff ratio. So what does this cutoff ratio means? We know that, what do we know? At 2, at 1 to 2, air is compressed, and from 2 to 3, fuel is injected and also ignited. Means the fuel injection starts in 2 to 3 and also ends in 2 to 3, and that is known as the cutoff ratio. That is known as the alpha or the cutoff ratio. The timing of the fuel injection and the ending of the fuel injection is 2 to 3. It is known as the alpha or the cutoff ratio. See here, alpha is the cutoff ratio. That is the fuel injection from 2 to 3. Okay, now there are some peculiarities about the diesel cycle. During compression, that is from 1 to 2, only air is compressed. Fuel is ejected afterwards. When it is ejected, from 2 to 3, the fuel is ejected. Heat addition is at a constant pressure. How? See here. In this graph, we see that the heat addition, that is from 2 to 3, heat addition takes place and heat addition is at a constant pressure. And see here, heat rejection. Heat rejection is at a constant volume. That is our last point. Heat rejection is at a constant volume. Okay, this was our lecture on the diesel cycle. In the next video, we are going to study the two-stroke engine, and the four-stroke engine. The peculiar differences between them is the point of study for us, and from the peculiar differences between them, we will understand both the concepts in a lecture. Thank you for viewing this lecture. Thank you.